The visitor has passed.
And most people have no idea it's happening.
3-Eye Atlas, the interstellar enigma that held the world's gaze for months, is now receding into the dark.
Something just happened in deep space that has every major observatory on emergency alert. The interstellar object known as 3-Eye/Atlas, the third confirmed visitor from beyond our solar system, just did something no natural object should be able to do. It changed course. Not slightly, not subtly, but in a way that violates every fundamental principle of celestial mechanics that we've relied on for centuries. 1 minute ago, new tracking data confirmed what scientists have been quietly discussing behind closed doors for weeks. 3-Eye/Atlas is no longer where it's supposed to be. Not according to NASA's Jet Propulsion Laboratory predictions. Not according to orbital models verified by institutions across the globe. Not according to the laws of physics as we understand them. The displacement is massive, 1.1 million kilometers from its predicted position. That's roughly 3 times the distance between Earth and the Moon. And this isn't measurement error. This isn't atmospheric distortion. This is a clean, verified deviation confirmed by multiple independent observatories across 4 continents. For the first time in history, the International Asteroid Warning Network, a United Nations-endorsed global defense coalition designed to protect Earth from cosmic threats, has begun actively tracking an interstellar object. Not because it poses an immediate collision risk, but because its behavior suggests something far more unsettling. Because if 3-Eye/Atlas really altered its trajectory while moving through our solar system, then what we're witnessing may not be astronomical anomaly. It could be intentional navigation. And if that's true, then every assumption we've made about interstellar visitors needs to be reconsidered immediately. This is not speculation. This is measured, verified data that's forcing the world's top astrophysicists to ask questions they never wanted to ask. What force moved it? Why did it move? And most importantly, where is it going now? The deviation that broke the models. The first hint that something was catastrophically wrong came from an independent research collective called Earth Exists. They weren't looking for anomalies. They were conducting routine verification, comparing live telescope observations with JPL's Horizon System predictions. The Horizon System is NASA's gold standard orbital calculator. It predicts where objects should be based on gravitational physics that has worked flawlessly for decades. When professional astronomers plan observations, they trust Horizons absolutely. But when Earth Exists compared 3-Eye/Atlas's actual position to Horizon's predictions, the numbers didn't match. At first, they assumed instrument calibration error. They recalculated. They cross-referenced with other observatories. They checked their math 3 separate times. The deviation remained, and it was enormous. 3-Eye/Atlas was 1.1 million kilometers away from where it should have been. Its distance from the sun remained consistent with predictions, but its position in the sky had shifted laterally, as if the object had somehow moved sideways through space. This is impossible under normal orbital mechanics. Comets can accelerate forward or slow down backward due to outgassing. Jets of sublimating ice that act like natural thrusters. This is called non-gravitational acceleration, and it's well understood. But these forces always push in predictable directions, away from the sun, along the direction of gas release. They don't push sideways. They don't create lateral displacement of this magnitude, and they certainly don't do it without visible evidence. To achieve the observed deviation, 3-Eye/Atlas would need a lateral velocity change of approximately 4 kilometers per second. That's more thrust than some of our own deep space probes can generate, and it would require either an enormous external force, which nothing in the solar system could provide, or an internal propulsion system. The implication sent shockwaves through the astronomical community, because if this data is accurate, then 3-Eye/Atlas isn't just drifting through our solar system following gravity. It's maneuvering. Within 72 hours of the Earth Exists announcement, the International Asteroid Warning Network issued an unprecedented directive. For the first time in its operational history, the IAWN, designed exclusively to monitor near-Earth asteroids born within our solar system, would begin tracking an interstellar object. The official reason given was to improve astrometric precision on unpredictable cometary bodies. But the timing revealed the truth. The IAWN only monitors objects that pose potential threats or exhibit behavior requiring heightened surveillance. And 3I/Atlas, moving away from Earth, poses no collision risk. So why activate global defense protocols? Because the object's behavior suggested something the agencies couldn't publicly acknowledge: intentional course correction, the physics that should prevent this. To understand why this matters so profoundly, you need to understand what doesn't happen in space. In the vacuum, nothing changes direction unless something makes it change direction. This is Newton's first law, and it's been tested billions of times. Objects in motion stay in motion. They don't just decide to drift sideways. When comets approach the sun, they heat up. Volatile materials, water ice, carbon dioxide, methane, sublimate directly from solid to gas. These jets erupt from the surface, creating visible tails and providing thrust that can slightly alter the comet's path. But these changes are always predictable. The gas jets away from the sun. The comet experiences force in the opposite direction. The acceleration is measurable, visible, and follows clear physical principles. 3. I/Atlas showed none of this. No sudden brightening that would indicate a major outgassing event. No visible jets or plumes. No expanding gas cloud. Every major telescope pointed at it during the period when the deviation occurred saw nothing. Just steady, unremarkable light from a distant object. And yet the trajectory changed dramatically. Avi Loeb, the Harvard astrophysicist who famously suggested that Oumuamua might be artificial, has been watching 3I/Atlas closely. On his anomaly detection scale, which rates objects from 1 to 10 based on likelihood of artificial origin, he initially rated 3I/Atlas a 4. After the lateral displacement was confirmed, he quietly upgraded it. The new rating hasn't been made public, but colleagues report it's now between 6 and 7. For context, anything above 5 suggests features inconsistent with natural formation or behavior. The comparison to Oumuamua is instructive. That object, the first confirmed interstellar visitor, also exhibited non-gravitational acceleration. It sped up slightly as it left the solar system, with no visible outgassing to explain the change. Scientists debated explanations for years. Some suggested exotic forms of outgassing we couldn't detect. Others proposed that Oumuamua was unusually shaped, perhaps a thin, flat object that solar radiation could push like a sail. Loeb went further, suggesting it might actually be a light sail, an artificial structure designed to be pushed by starlight. But 3I/Atlas is different. It's larger, it's more active, it's brighter, and its deviation is lateral, perpendicular to the forces that should be acting on it. No light sail model explains this. No outgassing scenario fits. The object moved in a direction that requires forces current physics cannot account for through natural means. The blackout nobody expected. Just when astronomers thought they had stabilized their observations, something happened that nobody anticipated. 3I/Atlas disappeared. Not gradually, not due to distance or dimming. It vanished completely from every observatory tracking it, and the blackout was total. It happened during what should have been a routine observation window. The object was approaching solar conjunction, the point where it would pass behind the sun from Earth's perspective. Even during conjunction, modern instruments can usually maintain some level of tracking through radio arrays and space-based telescopes positioned away from Earth. But for 47 minutes, every single deep space observatory lost contact. Not just optical telescopes, which can be blocked by the sun's glare, but radio telescopes, infrared arrays, and even instruments specifically designed to pierce through interference. The Very Large Telescope in Chile, silent. South Africa's Meerkat Array, no data. China's 500-meter fast telescope, complete blackout. Even NASA's Deep Space Network, which maintains contact with spacecraft billions of kilometers away, reported total signal loss from the object's position. This wasn't an observation gap. This was coordinated, simultaneous failure across every instrument type, every frequency, every method of detection. And when the object reappeared 47 minutes later, it was in the wrong place. But for 47 minutes, every single deep space observatory lost contact. Not just optical telescopes, which can be blocked by the sun's glare, But radio telescopes, infrared arrays, and even instruments specifically designed to pierce through interference. The Very Large Telescope in Chile, silent. South Africa's Meerkat Array, no data. China's 500-meter Fast Telescope, complete blackout. Even NASA's Deep Space Network, which maintains contact with spacecraft billions of kilometers away, reported total signal loss from the object's position. This wasn't an observation gap. This was coordinated, simultaneous failure across every instrument type, every frequency, every method of detection. And when the object reappeared 47 minutes later, it was in the wrong place. Based on its previous trajectory and velocity, 3I/Atlas should have emerged at a specific position in space. Orbital mechanics is precise. Given an object's speed and direction, you can calculate exactly where it will be at any future time. But when observatories reacquired the signal, 3I/Atlas was thousands of kilometers away from the predicted emergence point. Its velocity hadn't increased enough to account for the displacement. Its trajectory angle was off by multiple degrees. It was as if the object had skipped through space, as if 47 minutes of travel had somehow covered a different distance than physics allowed. Physicists reviewing the data are using careful language, but the implications are clear. The object performed what's being quietly called a nonlinear vector displacement. In plain terms, it changed position without traveling through the space in between. This violates everything: Newton's laws, Kepler's orbital mechanics, even Einstein's relativistic corrections for how gravity curves space. None of it explains what just happened. For an object that size to jump position requires forces or mechanisms that don't exist in standard physics. Either something external acted on it, something we didn't detect, or the object possesses capabilities that allow it to manipulate its own trajectory in ways we've never observed. And then came the detail that made everything worse: the signal that won't stop. During the blackout and immediately after, radio observatories began detecting something new. Not from 3I/Atlas's expected position, but from its actual position after the jump. A pulse. Low frequency, barely detectable, but unmistakably regular. It repeated every 247 seconds. Exactly. No drift, no variation. Just a clean, rhythmic beat emanating from the object's location. At first, astronomers assumed it was interference, perhaps an Earth-based signal bouncing off the object. But triangulation ruled that out. The pulse originated from 3I/Atlas's position in space, and it was coherent across multiple frequency bands. Natural astronomical sources don't behave this way. Pulsars emit regular signals, but they're neutron stars with specific formation histories. Magnetospheres can create patterns, but they're tied to rotating planets or stars. Nothing about 3I/Atlas, a small interstellar object, barely a few kilometers across, should be capable of generating a repeating electromagnetic pulse. But it was, and the pattern was too precise to be random. For a brief window, the signal was publicly accessible. Amateur radio astronomers in New Zealand and Argentina picked it up independently, recording at least 10 clean pulses before NASA's Deep Space Network servers went down for what was officially called emergency maintenance. By the time the network came back online, access to the raw data had been restricted. The official explanation: preventing misinformation while the signal was being properly analyzed. But backup mirrors across the internet had already captured the recordings. And when signal analysts examined the waveform, they found something embedded in the pulse. Not language, not an image. Binary data. The decryption process took days. Multiple groups working independently arrived at the same result. The binary sequence resolved into coordinates, but not galactic coordinates pointing to distant stars. These coordinates pointed inward, specifically to a location within Earth's orbital path, a precise point in space that Earth will pass through during the second quarter of the year 2031. This wasn't an impact warning. The coordinates sat well outside Earth's atmosphere, but it was unmistakably a rendezvous point, a location, a date, a scheduled intersection. Something had just given humanity an appointment, and we had approximately 6 years to prepare for it. The images NASA won't release. While the blackout and signal dominated attention, another mystery was quietly unfolding. NASA's Mars orbiters had been perfectly positioned to photograph 3I/Atlas during its closest approach to the Sun. The Mars Reconnaissance Orbiter and MAVEN spacecraft both have high-resolution cameras and spectrometers. During September, as 3I/Atlas passed through the inner solar system, both spacecraft had unobstructed views that Earth-based telescopes couldn't match. Those images should have been released by now. NASA routinely shares data from planetary missions within weeks of acquisition. It's standard practice, part of the agency's commitment to public transparency and scientific collaboration. But the 3I/Atlas images never appeared. Not a single frame, not even preliminary data or low-resolution previews. When journalists inquired, NASA's Planetary Science Division issued a brief statement. Data is being analyzed and will be released pending quality review. That was 3 months ago. No updates have followed. Internal sources, scientists working on unrelated Mars missions who have access to the imaging archives, report that the 3I/Atlas data exists, but has been classified under a designation typically reserved for national security concerns. Why would images of a comet be classified? One possible answer came from Avi Loeb, who mentioned in a recent publication that 3I/Atlas exhibited an anti-tail during its approach, a rare phenomenon where material appears to point toward the Sun rather than away from it. Anti-tails occur under specific geometric conditions and are well documented. But Loeb noted something stranger. After the close solar approach, the tail reversed. Suddenly, it began flowing away from the Sun again, as if the object had physically reoriented itself. No natural comet reverses its tail direction cleanly and rapidly. Tails are passive, shaped by solar wind and radiation pressure. They don't flip on command. But if an object could rotate itself deliberately, altering which side faced the Sun, the tail would appear to reverse. That kind of maneuver requires attitude control, thrusters, a guidance system. If the Mars images show geometric structures, reflective surfaces, or light patterns inconsistent with a natural comet, NASA would face an impossible choice. Release data that suggests artificial origin, or classify it and hope nobody notices the absence. The silence suggests which option they chose. The second correction. Just when it seemed the situation had stabilized, 3I/Atlas moved again. This wasn't the original lateral displacement. This was a secondary deflection, smaller but perfectly aligned with the object's original trajectory, as if it had corrected its own path. Ground-based observatories in Chile, Spain, and Japan independently detected the change. The movement was symmetrical, calculated, and exact. The kind of correction that a spacecraft executes after an automated navigation check. The International Asteroid Warning Network issued an internal alert designated Pattern Recognition Event, meaning the behavior matched no known natural phenomenon in their databases. Simultaneously, the European Space Operations Center released an encrypted update to member agencies, confirming that 3I/Atlas had produced measurable acceleration inconsistent with gravitational influence. In plain language, the object had fired something. But fired what? And why? When the Very Large Telescope in Chile analyzed infrared emissions during the maneuver, it detected a sudden spike in thermal radiation. The burst lasted exactly 12 minutes, then ceased completely, as if a controlled engine had ignited and shut off. The thermal signature didn't match any known chemical propulsion. It didn't resemble ion drives or solar sails. Instead, the heat curve most closely matched what theoretical physicists call magnetohydrodynamic acceleration, a process where charged plasma is accelerated through electromagnetic fields. This is technology humanity has theorized for interstellar travel, but never built. And here it was, apparently being used by an object that entered our solar system from the void. The object's rotation rate, previously stable, began fluctuating in precise harmonics. Each variation lasted exactly 247 seconds, the same interval as the pulse signal. Scientists initially thought it was tumbling, but the pattern was too precise, too mathematical. It wasn't chaos. It was structured communication through motion. Every rotation, every pulse, every course correction, all synchronized to the same temporal pattern, as if the object was broadcasting its status through multiple channels simultaneously. The Jupiter alignment. The new trajectory revealed something even more concerning. 3I/Atlas wasn't heading toward empty space. Its adjusted course pointed directly toward Jupiter. Not a collision course. The object would pass safely beyond the gas giant's atmosphere, but close enough to enter Jupiter's magnetosphere, one of the most powerful magnetic environments in the solar system. Orbital analysts calculated that within months, 3I/Atlas would pass through this region at precisely the right angle to execute a gravity assist. The same maneuver spacecraft used to gain velocity or change direction by slinging around a planet. If this was coincidence, it was extraordinary. But if it was deliberate, it meant the object was planning ahead, using Jupiter's gravity to reshape its trajectory with perfect precision. This is what spacecraft do, what probes designed by engineers do, not what rocks drifting through space do. NASA elevated its monitoring status to what internal documents call Level 3 contingency, meaning the object's movement was considered active, intentional, and increasingly unpredictable. And then, as global attention reached peak intensity, every observatory tracking 3I/Atlas went dark simultaneously. The second blackout. It happened without warning. In less than 10 minutes, telemetry from observatories in Hawaii, Chile, Italy, and South Africa froze completely. The deep space network lost contact. Even China's radio arrays reported total silence across all frequencies. This wasn't equipment failure. This was coordinated, systematic shutdown. When the data streams resumed 47 minutes later, the exact same duration as the first blackout, they all showed the same thing. 3I/Atlas had vanished from every registered coordinate. Not dimmed, not obscured. Gone. But a faint echo remained. A low-frequency hum, undetectable to human hearing, but measurable by sensitive instruments, pulsed across the detection network, once every 247 seconds. The signal was still there, still broadcasting, still marking time. But the object itself had disappeared. Scientists initially assumed it had passed behind another celestial body or moved beyond detection range. But cross-referencing with star charts and planetary positions ruled that out. Nothing blocked the view. Nothing explained the vanishing. The International Asteroid Warning Network officially classified the event as Interstellar Signal Anomaly 2025-11 and immediately restricted access to the data. But one detail leaked before classification locked down. During those 47 minutes of blackout, multiple telescopes briefly registered a flash. Faint, directional, aligned perfectly with Jupiter's orbital position. The object hadn't disappeared. It had jumped. Again. And when instruments detected it moments later, it was moving at a velocity that shouldn't have been possible without sustained acceleration over weeks. It had gained speed instantaneously, as if something had boosted it beyond the constraints of normal physics. Physicists call this instantaneous vector relocation. In practical terms, it means the object changed position faster than continuous travel through space would allow. And that shouldn't exist. The coordinates that changed everything. When analysts reconstructed the data from the second blackout, they found something that had been embedded in the network itself during those 47 minutes of silence. A transmission, not from Earth, not random noise. A structured binary stream synchronized with 3I/Atlas's 247-second pulse pattern. When decrypted, it formed coordinates, but not spatial coordinates pointing to distant stars. These were temporal coordinates, a location in space matched to a specific point in time. The position, Earth's orbital path. The time, second quarter, 2031. At first, analysts dismissed it as corrupted data, but as reconstruction continued, the pattern became undeniable. The coordinates weren't approximate. They were precise to within kilometers, indicating exactly where Earth would be in its solar orbit 6 years in the future. The file was immediately classified under Asteroid Hazard Level 10, the designation reserved for civilization-level threats. Every national space agency denied its existence. But 3 months later, amateur astronomers in Australia began picking up faint echoes, the same 247-second pulse. But this time, the signal originated from inside the asteroid belt, not from 3I/Atlas's last known position. The pulse wasn't fading, It was multiplying, as if something else was now responding. Project Helios and the preparation. Shortly after the second blackout, internal documents from multiple space agencies began referencing a program called Project Helios. Previously listed as a theoretical study of solar sail technology, the project had been quietly reclassified. Leaked memos describe it as a multi-agency initiative spanning NASA, ESA, and select Asian observatories. The stated aim, not just to observe 3I/Atlas, but to intercept it. The European Space Agency's Comet Interceptor mission, originally designed to park in space and await unexpected comets, has had its flight path assumptions modified. The mission was always meant to be adaptive, launching early and waiting for a target to appear. Now it has a name and a timeline, and scientists developing its payload have begun preparing for scenarios that weren't in the original mission brief. Because if 3I/Atlas is returning to that 2031 coordinate, and if our agencies are designing missions to meet it there, then the question becomes, who is leading this encounter? Did we decide to intercept? Or did something else schedule the meeting and simply inform us of the time and place? The resonance. The most disturbing development is what's happening to Earth's observation networks. Radio interference across multiple observatories has begun synchronizing, all of it matching the 247-second pulse from 3I/Atlas. It started subtly, slight periodic noise in background data, easy to dismiss. But over weeks, the pattern strengthened. Now, instruments across the planet are picking up the same rhythmic signal, even when not pointed at the object's location. It's as if the entire detection network is resonating with whatever 3I/Atlas is broadcasting. As if the object isn't just sending a signal, but tuning our instruments to its frequency. And then the echoes began appearing, weak secondary pulses from different locations. The asteroid belt, the outer solar system, each one separated by 247 seconds. Each one slightly different in tone, as if responding to the original. Scientists monitoring these signals can't agree on what they represent. Relays, probes, fragments left behind, or something else entirely. Communication between parts of a distributed system that we're only now beginning to detect. The wall going up. As evidence accumulated, something changed in how information flowed. Observation logs that had been publicly accessible were quietly removed. Data feeds went offline for system maintenance and never returned. Research papers submitted to journals were withdrawn before publication. The International Asteroid Warning Network shut down all public data streams. The official reason, system restructuring. But insiders describe something different, a coordinated effort to control what information reaches the public and when. NASA's Planetary Defense Coordination Office stopped issuing updates on 3I/Atlas entirely. Queries redirected to generic statements. Press conferences canceled. Scientists who had been speaking openly about the anomalies suddenly declined interviews. The wall wasn't going up because there was nothing to report. It was going up because there was too much to report, and no consensus on how to explain it without causing panic. Because how do you tell the public that an interstellar object just executed maneuvers that violate physics, broadcasted coordinates for a future encounter, and might be part of something larger that we're only beginning to detect? How do you explain that we might not be observers anymore, but participants in something we didn't choose and don't control? What happens in 2031? The countdown is not theoretical. 6 years from now, Earth will pass through the coordinates embedded in that binary transmission. Whether 3I/Atlas returns to that location remains to be seen. But preparations are already underway. Project Helios is reportedly operational, though details remain classified. The Comet Interceptor mission continues development with mysterious payload modifications. And every 247 seconds, that pulse continues, fainter now, dispersed across the solar system, but persistent, rhythmic, waiting. If this was simply a rock from another star system passing through, the story would have ended months ago. But rocks don't correct their courses. They don't broadcast coordinates. They don't schedule encounters years in advance. Something is coming, or returning, or already here, distributed across space in ways we're only beginning to detect. And in 2031, we'll find out whether that binary message was an invitation, a warning, or simply notification that we're part of something larger than we realize. The world may have stopped watching 3I/Atlas, but the universe hasn't stopped watching us. If this story made you question what's really moving through our solar system, what intelligence might be guiding something across the stars, don't look away now. Subscribe to this channel. We document the discoveries that agencies won't fully disclose. Turn on notifications because when 3I/Atlas returns, if it returns, you'll want to know what happens next. The countdown has already begun, and whatever scheduled that meeting in 2031 didn't ask for our permission. It just told us when to be there.